In this video, I'm going to demonstrate an excitatory and inhibitory neural circuit. This is a basic neural circuit consisting of 3 neurons. In the middle is an excitatory neuron that will increase the likelihood of an action potential. We start with glutamate, one of the main excitatory neurotransmitters in the central nervous system in the synapse. One of glutamate's main receptors is AMPA, which is a ligand-gated or ionotropic receptor. Glutamate will attach to the receptor and cause it to be permeable to sodium. Due to the equilibrium potential of sodium being about positive 62, it will rush into the cell and act to depolarize it, causing an EPSP, or excitatory postsynaptic potential. The depolarization of the EPSP gets the membrane potential closer to the threshold for firing an action potential. The EPSP will passively spread from the dendrites to the axon hillock where the action potential is triggered. Voltage-gated sodium channels will open, and sodium ions will rush into the cell in the rising action portion of the action potential. At the peak, voltage-gated sodium channels will close, and voltage-gated potassium channels will open. Potassium has an equilibrium potential of around negative 80 millivolts, so it will rush out of the cell to repolarize. The channels are slow to close, so the cell will hyperpolarize a little before returning back to the standard negative 70 millivolts. Through saltatory conduction, the action potentials will spread down to each node of RNVA in between the myelin sheaths until it reaches the axon terminal. Here, the depolarization causes voltage-gated calcium channels to open, and calcium will enter the cell. This is a small synaptic vesicle containing glutamate. Calcium binds to synaptotagmin, a protein that is part of the V-snare complex. V-snare will communicate with T-snare to fuse the vesicle with the membrane and release glutamate into the synapse. The glutamate can then bind to an AMPA receptor on the postsynaptic neuron and repeat the same process. So this is our basic excitatory neural circuit. This is an example of a neural circuit with an inhibitory neuron. The process starts the same, with glutamate attaching to an AMPA receptor on the neuron and passively spreading an EPSP to the axon hillock where it initiates an action potential. The action potential again spreads from node to node until it reaches the axon terminal, where it will cause the release of calcium that attaches to synaptotagmin on the vesicle. The vesicle in the inhibitory neuron will contain GABA, the main inhibitory neurotransmitter in the central nervous system. When GABA is released into the synapse, it will bind to a GABA-A receptor. The GABA-A receptor is ligand-gated or ionotropic, and when GABA binds, it becomes permeable to chloride. Chloride is an anion, so it will decrease the membrane potential of the cell, causing hyperpolarization and an IPSP. An IPSP is an inhibitory postsynaptic potential, which brings the cell further from the threshold potential and thus will not fire an action potential. So this is our basic inhibitory neural circuit. Okay, that was excitatory and inhibitory neural circuits. Thank you for watching.